So unit step function is mathematically this. 0, 1, if t is less than 0, if t is greater than a, I'm sorry. Okay? If you draw it, this is a, right? This is 0. So if t, this is time, right? T is less than a, that's 0. Okay? It's all 0. And if time is greater than 1, I mean a, that means 1. Okay? So that's the unit function, unit step function in graphical form. Okay? So this is u of t. So u of t is what? U of t is this. Right? So a is 0, so it's all 1. That's u of t. So let's take a Laplace transform of u of t minus a. So Laplace transform of t. So Laplace transform of the unit step function, right? Shifted way, in a shifted way. This is from 0 to infinity, right? E to the minus st times u of t minus a dt. Okay. So if you do that, since less than a is all 0, right? So there's no integration for that part, right? So it's a to infinity, right? E to the minus st times, if it's greater than 0, it's all 1, right? It becomes like that. Okay? All right. So this is minus e to the st over s from a to infinity. Okay? So finally, it's e to the minus as over s. So Laplace transform of unit step function shifted at a, right, is this. So let me give you an example of how to use unit step function. Okay, let's say we have f of x, which is sine function is 5 sine t. Okay, let's say we have this function, and if you draw the graph, that, right? So it's a 5 and pi over 2. This is pi, this is 2 pi, this is 5, right? That's the function. Right. What about this? F of t, f of t times u of a t, t minus 2. Okay? So with this original function, you're multiplying the unit step function that is shifted at 2. Okay? Then what's going to happen? The original function, right? And you have u times t minus 2. So at 2 is about here, right? Okay. This is 1, okay? So that's u of t minus 2, right? And you're multiplying, okay? You're multiplying, so up to here, it's all 0, right? 0 times something is 0, correct? And something times 1 is something, right? So the curve becomes this. 0 all the way to 2, right? And then it suddenly jumps because it jumps to be 1. So it becomes like that. And beyond 2, it's all original function, right? 이걸 뭐라 그래요? Is this shifting? Is this shifting of original function? No, this is on and off. Okay? if you simply multiplying this, right, the unit step function, that means on, this is off region, this is on region, right? You have to clearly understand this. Okay? Then last case. What about this? That's the shift that we want. Okay? So it's not just time, u, but t has to be shifted also in the original function. Then the function will be this. At 2, it's exactly the shift that we want. Square function, okay, or pulse. Okay? So it's like this. From A to B, this. It's 1, 0. Okay, that's the square function. This is basically this is nothing but the addition of superposition of two unit step function. Okay? This is this. So from A, so one step function is this. And second step function is okay, if you add them up, the final, shape will be, and it's a plus minus, minus 1 plus, 0. It becomes this square function. Okay? Because why do you need that? Remember this? It's all square. Here it's square there, right? It's finite, region there. It's a square. It's square, not unit step function. This is u of t minus a minus u of t minus b. This set, okay? You're going to use this frequently, more often than just, unit step function alone. Okay? Because it's a minus, b. Okay, so let me give you an example one more time in the textbook. It's also in the textbook. So what about this? U times t minus 1, 2 times u t minus 4, plus u times t minus 6. So addition of many unit step function is really it occurs many times. So you have to understand that well. Okay. All right. What's going to happen is this. So t minus 1. So it starts from 0, t, 1. It's 1, right? And at 4, we have minus 2. So it goes to minus 2. Right? And at 6, it does that, right? And you add them up. You're adding them up. And finally, it's a 0 all the way here, right? And it jumps to 1 till 4, right? And then it's plus 1 in this region. It's plus 1 and minus 2. So minus 1. Okay? And then this is 1. There are 2 1s, right? Plus minus 2 becomes 0. Okay? So this wiggly, shape is the function by this. What about this? Sine 1 over 2 pi t times u of t minus u t minus 2 plus u t minus 4 minus plus we have this. With this at t, so it's a t is this, right? And at 2 is here. This is 2, 4, 6, 8, 10, right? So at 2 is minus 1. At 2 it becomes minus 1, so it becomes 0 here, right? And this minus 4 is again 1, right? And it again 0, right? So it's 1 here, 1 here, 0 here, 1 here, right? It means on and off. So at the end, only this part left. This is on, right? Because 1 is there, right? It's on. And here is off, right? 0. So it's off. And on, off, on, off. Okay? So this is the function that makes this happen. So the second shifting theorem, which is t shifting, is this. So Laplace transform of ft minus a times ut minus a is e to the minus as f of s. Okay? So this is exactly the definition of shifting in time, right? Is multiplying exponential function in the S domain. Do you see that? S shifting it was in reverse, right? S shifting was shifting was e to the a t function of t is f of s minus a. Right? So shifting in S domain becomes, multiplication of exponential function, right? But in t shifting, on the other hand, if you multiply exponential function in the S domain, that means exactly the time shifting. What about this? The function is given t 2 and 0. So it's t is this, right? 1t is this. T is greater than 3. Wow. Okay, if you draw that function, that is 1, 2, and 3, right? So from 0 to 1, that's t. Okay, so it's a t. So it's t here. It's 1. Okay? And 1 to 3, it's 2. So it's here. Okay? And the rest is 0. So f of t mathematically is this. So t, we have first function t, right? So t times u of t minus, it's a block. I told you, it's a square function, right? Square function means it starts from 0 and it ends at 1, right? So it's a t minus 0 minus u of t minus 1. This is full writing of this square function. This is first square function, right? This is exactly this. And another square function is this, right? Let me change this, right? That's second square function, right? And third square function is this. It's infinity, actually, right? So if we write that, that's plus 2, and second, function is 2, right? The constant. 2 times u of t minus 1 minus u of t minus 3. Okay? And the last one is 0, although it's 0 times u of t minus 3 minus u of t minus infinity. Okay, so if I write it again, the function is t plus 2 minus t times u t minus 1 minus 2u t minus 3. Okay, if we rewrite this, that's it. Okay, we need to do the Laplace transform of that function, right? This function, if we are able to, write in the good mathematical form, we can transfer that to Laplace domain, right? By doing this. So L of f is L of t plus L of 2 minus t u t minus 1 minus 2 L of u t minus 3. Okay? So the number 1, this one, is 1 over square, right? This is 1 over square. If you go to the, and if you go to the table, this is the, definition, right? U of t, so that's e to the minus 3s over s. Okay? And this one is trouble. Okay? We need to get the Laplace transform of that by doing this. So, for this, if it is a shifting, okay, if you have u of t minus 1, that means shifting, right? It should be a formal shifting, means this part has to be t minus 1, right? For formal shifting, that part has to be f of t minus 1. Okay? So that starts from there. So f of t minus 1 is 2 minus t. Then it's a formal shifting. Okay? All right. So f of t is 2 times minus t plus 1. Right? You're simply substituting back. So it's a 1 minus t. You're guessing function of t by having the shifted relationship. Okay? So from this t shifting, right? If you have this formal shifting expression, that means e to the minus as times f of s, right? So we are applying that theorem. So that's e to the minus s, because it's minus 1 times 1 over s minus 1 over s squared. That's the second term. Okay? So the whole thing is 1 over s squared plus e to the minus s 1 over s squared minus 2 times e to the minus 3s over s. The function, is getting harder. Okay? It's kind of complicated in this way. T, 0, t is 1, 1/2 t squared, 1, 2, pi over 2, cosine t. T is greater than pi over 2. Wow, it's much harder, right? Harder than previous one. So it's a more complicated function there, but still piecewise. Still piecewise. Naturally, we have to use second shifting theorem, right? Hey, let's do it. So f of t is 2 times 1 minus u of t minus 1. Okay? You know that this is u of t, right? And plus 1/2 t squared. So u minus 1 minus u of t, of u of t minus 1 minus u of t minus pi over 2. Okay? All right. And plus cosine t times u of t minus pi over 2. And it's minus infinity is 0, right? So that's it. That's the function f is with respect to the square functions. Okay. And the Laplace transform of the first one, this is 2 and minus 2 times u of t minus 1. This is from table, right? No trouble. And so we have to get 1, 2, and 3. 3 functions using SST, right? Okay. So the first one, Laplace transform of the first one is t squared times u of t minus 1. Okay? So if you do that using SST, second shifting theorem, what you can write is this. T minus 1 square, right? So t becomes t minus 1. Then this is very different from this, right? You have to, add the canceling terms like this. So 1 plus 1/2. Yet times ut minus 1. Actually, this, right? So we are simply writing this part using second shifting theorem, f of t minus 1, right? Okay. And then the calculation is this. So u e to the minus is minus s, right? Times the function, original function is t squared, right? So t squared is this. So 1 over s cubed plus 1 over s squared plus 1 over 2s. Okay? Since we have, 1/2 is there, right? And second one is in the same respect, it's the same, okay? So u t pi over 2. If I write it on the second page, Laplace transform of 1/2 t squared times u of t minus pi over 2. Same thing. 1/2 t minus pi over 2 square, right? F of t minus 1, same thing. Plus pi over 2 t minus pi over 2 plus pi square over 8 times u of t minus pi over 2. Can you find this? Here to here? From here to here, yeah, probably you can. If you calculate this, you can find it. But from here to here, it's kind of, tedious job. And sometimes it's not clear. I mean, this is easier case. It's a square, right? Quadratic function. What if it's a cubed? Power of 3 or 4s. Then, it's impossible. It's nearly impossible to get this, right? So this method is kind of trouble there, right? Anyway, let's take it, right? And the last, one is cosine t times u of t minus pi over 2, which is Laplace transform of minus sine t minus pi over 2 times u of t minus pi over 2, and that's minus 1 over s squared plus 1 e to the minus pi s over 2. I'm going to, derive the alternative of second shifting theorem. What happened? Right? Second shifting theorem, which is this. Okay? Is this. Right? You have to do this, right? So we're going to use the second method, the alternative, to calculate that. All right. So f of t was 2 times, again, 1 minus u of t minus 1 plus 1 half t square u of t minus 1 minus u of t minus pi over 2 plus cosine t times u of t minus pi over 2. Yeah, I didn't need this bracket. So let me just write the second one. Okay, so Laplace transform of t square u of t minus 1. Okay, 1/2, I'm just letting it out. So that's, according to the alternative theorem, we just take, that's f of t, okay? That's u, and we use this, we multiply e to the minus as times Laplace transform of f of t plus a. Okay? That's what we do now. So e to the minus s, because a is 1, right? Times Laplace transform of the original function is t squared, and you have to make t plus a, which is t plus 1 square. And that's it. Right? That's the alternative of the SST. And if you calculate it, that's this is t s times Laplace of t square plus 2t plus 1, right? So it's factorial plus 2 over s square plus 1 over s. Okay? That's that easy. I mean, you don't have to worry about, converting this to the, t minus a type. All you do is, t plus a in the Laplace transform. Okay? And the second one, another important one was u of t minus pi over 2. That makes, things hard, right? So what you do is same thing, e to the minus s times L of t plus pi over 2 squared. Okay? This is actually a was pi over 2, so it's a pi s over 2. Right? Okay. And pi s over 2 times, which is 2 factorial over s cubed plus pi over s square plus pi square over 4s. Okay? So it's fairly easy. Everything, gets easier than the previous one. So what you do is use this second, alternative of this SST all the time.